this video is going to be a brief recap of an arithmetic versus geometric sequence and the difference between them. So in an arithmetic sequence, we have an adding or subtracting pattern. And they follow a linear pattern or a linear function. We don't connect sequences when we graph them, but if we were to connect them, in arithmetic, it would be the shape of a line, a linear function. For geometric, it is going to be multiplying or dividing. Remember that when we are dividing, for example, if I'm dividing by 4, that's the same thing as multiplying by 1/4. And when we're talking about geometric sequences, we want to steer towards the multiplication only because of the formula. But any division can be turned into a multiplication. And in terms of functions, these follow an exponential pattern and model an exponential function. Each of these have an equation for explicit formulas, and they can be found on the reference sheet. You do not need to memorize them. For arithmetic, it's a sub n equals a sub 1 plus n minus 1 times d. A sub n is the nth term, or any term I can plug in for n because n is the term number. So for example, if I'm looking for a sub 5, I'm looking for the 5th term. So a sub 1 is the first term. And d is the common difference. And that's what's changing every single time. So that follows your pattern. If I'm adding by 5 every single time, my common difference is 5. For geometric, it's a sub n equals a sub 1 r to the n minus 1 power. A sub n, a sub 1, and n are all the same. The only difference in this formula is r, and that's the common ratio. Once again, it's what you're changing by, but this time I'm not adding, I'm multiplying. So let's take a look at an example for each. For arithmetic, let's say my sequence is 3, 6, 9, 12, and so on. Let's start with a recursive formula. In a recursive formula, remember we need a first term, and then we need a pattern that shows the previous term plus something, the previous term plus something. Or if it's multiplying, the previous term times something, the previous term times something. So here, my first term is 3. That's easy to identify. And each time I'm adding 3. So my recursive formula would be a sub n minus 1 plus 3. And both of these pieces are needed for my recursive formula. If I'm doing an explicit formula, I'm going to start by copying down the formula on the reference sheet. A sub n stays, it's like a y equals. My first term is 3 plus n stays because that's like the x in your equation, and d is your common difference, what's being added or what's changing every time. And remember, this is really multiplication even though it doesn't show it, so I'm multiplying by 3. So we could leave it like this, or sometimes on a multiple choice they may simplify this by distributing that 3 into our equation and then combining like terms. But we can stop here. So that is an example of an arithmetic sequence where I wrote the equation recursively and I wrote the equation explicitly. Let's take a look for geometric. So if I have a pattern 4, 8, 16, 32, and so on. Let's start with recursive. So remember, once again, recursive, I need two pieces. First piece is my first term, which is 4. Then I need to find the pattern. What's happening? Every single time I'm multiplying by 2. So it's the previous term times 2, which you will usually see this written as 2 times the previous term, because we have a habit in math of putting the coefficient in the front. So my equation would have both pieces, and that would be my final answer. And then let's take a look at explicit. So once again, for explicit, whether it's arithmetic or geometric, doesn't matter, but you start by copying down the formula from the reference sheet. Since it's geometric, I'm copying down the formula a sub n equals a sub 1 r to the n minus 1 power. My first term is 4. My common ratio is what's being multiplied every single time, which is 2. And then n minus 1 stays because my n is like an x in an equation. You cannot go any further in geometric. You cannot multiply that 4 and that 2. They have to stay because remember, the 2 is the base, the 4 is the coefficient. Go back to exponentials. The 4 is my initial value. The 2 would be my growth factor. So just keep that in mind. You cannot go further for a geometric explicit. So these are just two basic examples. There are a lot more videos and a lot more examples in your notebook that you can refer to if you need.